Hi everyone, welcome to MacMon.io. My name is Johnny Mac. I'm a software professional and host of this channel. Thank you for tuning in. Check out this video about how to configure an RPI image built with rpi-image-gen and ensure that all the space on the SD card or the USB drive is made available when the device boots up. I'm really glad to see and hear all the feedback and that you're coming forward with your experiences. I have a huge list of topics to make videos on, not just for the Raspberry Pi, but for blockchain and AI topics as well. But I want to be sure to prioritize your requests because you're out there trying things, you're trying this stuff out, and I'm just one guy here with my perspective. So the question from Dude Man is here, which is, do you need to resize the rootfs to expand the partition to 100% of the USB drive that's plugged in so the full disk space is taken advantage of? And so you might recall with rpi-image-gen, the way that I'm framing this is we're creating a mold and then we're going to cast the image from that instead of taking a stock image and whittling away to get the result that we want. And under the hood, rpi-image-gen uses bdebstrap to create a Debian root file system from the image layout that we configure, right, with our external directory and our YAML files. That goes as input to bdebstrap. And we see bdebstrap here is really just a wrapper for another utility called debstrap. And that's really useful to know. We can get into the details of that maybe in another video, but the point is that we have now our rootfs, and then under the hood, rpi-image-gen is using genimage to actually build the image file, right? And this is a utility. Here is the documentation for this utility. And we can see here that essentially you're taking the contents of that rootfs, you're gonna put it into a single file that can then be read. Now, what's interesting about this image file is that it includes the size of that ultimate partition that you are going to then see when you install this image file, right? Or you use a utility like RPI-Imager to install this image file on the SD card. So when we look at the configuration for genimage, size is an input that you can specify, right? And it says here, size of this image in bytes, K, M, or G, can be used as suffix to specify the size in multiples of 10, 24, etc. The suffix S specifies a multiple of the traditional sector size of 512, okay, blah, blah, blah. You can also use a percentage. And when we look here back at rpi-image-gen, if we look at one of the provided default configs, right, apt simple, then we see that this is where we're configuring that size, right? This is going to get passed into genimage and the boot partition size and the root partition size. And these are defaults that are included in this generic apt simple config that Matthew Lear has provided, and he's using 200% for the boot partition size, 300% for the root partition size. What this means is that essentially the size of the contents, right, of your bits is then going to be multiplied by this number for the boot partition and the root partition. But that number is derived from how many bits are in your image layout, right? As a result of the files that you are configuring that are specific, but also, you know, the packages that you install from your customizations, right? And so that is going to be dynamic based on that mold. And what is being requested here by Dude Man is I want to expand the partition to 100% of the USB drive, right? Regardless of how many bits I have or how big the partition is that I specified for genimage. And so that's possible. Yes, of course, there are some trade-offs there, right? And so one thing that I would say is one of the virtues of using something like rpi-image-gen is that we're in control of what the image is from its inception, right? Rather than using that whittling method where there may be things that we need to remove, unexpected consequences of removing them and that sort of thing. And if our goal is to optimize the result, then we want to take some time to understand, in addition to the application requirements, which are the bits we're casting here, what are the additional resource requirements, specifically disk and memory requirements, right? And if we know this beforehand, then we can limit production costs on storage, right? Like the micro SD card, for example. And we can optimize that experience by presetting our image with that allocated space, right? Okay, but you're asking, hey, Johnny, that's great and all, but my product manager is saying like he wants 4 versions of our device. It's a handheld field IoT sensor reader for the gas mining industry, and we're gonna have a 4, 8, 16, and 32 gig version. Are you saying I need to build 4 different images for my production team? They need to be sure then to load that correct image on each card. That seems like a lot of risk. Can't I just have one image that when it boots, it dynamically determines the partition size? And yeah, for sure, this is a use case that's gonna come up. And I always advocate for pursuing that ideal solution, but that might be in the end something where we're doing an extra step at boot time. So let's see how we can dynamically resize. And I'll point out some of the costs of this beyond just adding this code to your layout. So let's go ahead and hop over to VS Code here. I'm going to just bootstrap this project with our Docker file so we can run rpi-image-gen in a Docker container instance. And then I'll add the external directory basic layout and we'll go from there. Okay, so we now have our essentially basic layouting. You may see it's familiar. It's a configure, a metadir that will populate with some customizations YAML, a profile, and that profile should look like this. Okay, and it's going to reference this customization, so we want to add that. Okay, and then the config. This is going to be familiar again. I'm using the pi4 here, which I'm not going to include the device directory here. That's going to make rpi-image-gen reference its top level directory. So this might simplify things a little bit if you have a pi5. If you don't include the device directory here in your layout, it will refer to the top level, which does have now a pi4 and pi5 directory. However, if you do need to customize your command line, which we don't for this project, but if you do, then you will need to include a device directory in your layout. Okay, so our image then, sticking with MBR simple dual, and here we're just going to specify 125, 125 for our boot and root partition sizes. Again, this is where we could go in and be a little more specific and say, oh, I know I have a 4 gig limitation here, right? So I can go ahead and say 4 gigs. What that's going to do is create an image that will be 4 gigs. This will take a little bit longer, right? So that's one of the trade-offs of doing it up front is you would have a bigger image and a longer process to create that image and also load that image onto the card. However, it would then not require a dynamic configuration when it boots the first time, which is what we're going to see is going to happen here when we implement this strategy. So again, trade-offs, right? Build time versus runtime. And then the rootfs file type here. Okay, so for customizations, this is pretty simple for this one, guys. We're just going to include a few packages here, right? DOSFS tools and E2FS progs and fdisk. These are the tools that we're going to need to ensure that we can dynamically resize that disk when the device first boots. Okay, and then I do want to call out here when we look at the profile, right? We are including something called RPI miscellaneous utils. And this is going to give us, if we hop over here, raspi-config. So raspi-config is a package that includes some utilities that we can then use to do certain things that are specific to the Raspberry Pi or common on the Raspberry Pi. And if you've installed the base Raspberry Pi image, you might be familiar with raspi-config. So that's what we're going to use for this. And this is how the Raspberry Pi image does it. When you first boot, it's going to essentially execute this same pattern that we're going to implement right now to dynamically size your partition. That's cool to know. So let's come back here to our code. And maybe it's a good idea. Why don't we go ahead and build the image with this configuration, and then we can see what the disk partition size is. And then we'll add that customization to run raspi-config expand rootfs, and you can see what it looks like then. Okay, so let's go ahead and see what happens when we look at the disk partitions on when we boot up the device now. Okay, so here it's asking us to log in. And great, and so we can just go ahead and use df. And we see here that the size of the dev SDA2 disk partition, that's our root partition, is 502 megabytes with 85 megabytes available. And there's a few other utilities we can use to look at this, but that's basically the issue here, right? Is that the drive has 32 gigs, right? And so the ask from Dude Man is, what do we need to do to make that space available? So let's go ahead and implement that next. Okay, so to set this up, what we're going to do is we're just going to create a script, and that's going to come here in the device rootfs overlay that we're going to write out to user local bin. And this script is going to be called expand rootfs.sh. And really important here, we need to remember to set permissions on this file so that it is executable. And so we'll go ahead and do that. These are okay, and chmod. So that's done. So now the contents of this is pretty simple. We're going to check for that first boot flag, and that's just going to exist in the form of a file. And if it's not there, we're going to run raspi-config expand rootfs. Then we're going to write out that flag in the form of that first boot done file, and then we're going to execute a reboot. Now, there is a reboot utility, but we haven't installed that. It exists as a separate package. And so this is a way to manually trigger a restart. So we then are going to, similarly to some of my previous videos, what we're going to do here is we're just going to create a systemd service that we can then set up so that it will run on first boot. So we'll go ahead and create a directory here, root partition size conf. Okay, great. And then in there, we're going to have this systemd service that's just going to be called expand rootfs service. Okay. And that's going to look like this. Okay, and we want to make sure we're running this as the root so that we can trigger that reboot mostly. That's important. And then finally, we want to now create a customized script. You might recall that this is how rpi-image-gen works. It's going to look for these customized scripts when it bdeb-strap. And for those of you that haven't seen that, maybe it's worth showing that. This is here in this bin runner. And this is what is passed to bdeb-strap, and it's going to go ahead and look for any files that are prefaced with customize in this bdeb-strap directory, and this is our IG image layout. Okay, so let's go ahead then and create customize, and we'll call it root part resize. And here we go there. So root part size. Okay. And we need to preface that with customize so that it gets picked up. Okay. And then this is just going to rsync our file here. Root partition resize conf, I think it is here, resize conf. And that's going to write that out to systemd system. And then we want to make sure that we enable that so that it runs on first boot. Okay, great. And the last thing we need to do, I think, is, no, I think that should be enough. So we have our packages that we need to run raspi-config, the command here, expand rootfs. And then we have set up a systemd service. And now we're making sure that gets written to the right location and enabled on first boot. So what we should see happen is that we're going to see the device boot twice, and that is the cost that we are going to incur here is that on first boot, the device is going to boot twice. And that's not great, but it's probably not the end of the world, and it will allow for a dynamic type of programmatic determination of how big is the disk, and it will allocate it dynamically for you. So let's go ahead and build this image and then see what it looks like when we boot the device. And just what happened there, if you saw, there was an error. I'm reusing the container that we used to do the previous build. And so I had a dirty working directory, and rpi-image-gen was informing me of that. So you saw that I went ahead and cleaned up the working directory there, just removed that workdir from the rpi-image-gen subdirectory, and you can then start the tool again. Okay, so let's go ahead and see if we pop it in. What is the result? Okay, so now we're booting up, and what we should see is we're gonna expect this to boot twice, right? So we see the rainbow screen there. Now we would think that our expand rootfs is happening, and then it's gonna reboot. And there it does, okay. And now when we get the login prompt, which should happen here in a moment. Okay, great, you can log in. Okay, excellent. And now what we see is, sure enough, if we look at our SDA2, it's now 29 gigs, right? And 27 gigs available, which is exactly what we want. And so the cost of that, right, was that double boot. Was that a big deal? No, I don't think it was that big of a cost, actually, all things considered. And that's going to make for a much faster image writing, as well as a faster imaging of the actual cards, right? And so that's going to be helpful. I think those are two steps that we do gain efficiency. And those are important steps, right? To be able to write and build that image quickly, and then to write it to the SD card quickly, that's an advantage, I think, over presetting the disk size. Some trade-offs there, but we do see now that we can get this achieved. So that's it for this video. Thanks for tuning in to learn how to use rpi-image-gen to configure your image so that it automatically resizes the root partition when the device first boots. I hope you learned something from this. If you did, please click that like button. Really helps me out, gives others a chance to see this content. And also please consider subscribing to the channel if you haven't, and really appreciate the comments and the feedback and the questions. Thank you to Dude Man for bringing this question to my attention. If you have any other questions, I know that there are others that have questions. I'm going to look to make videos on those questions as well. I hope you're having a great day, and remember, don't stop experimenting, challenging assumptions, and seeking the objective truth. I'm Johnny Mac. This is MacMind.io.